We will now discuss the solution of a problem from the section Differential Calculus. The problem is on the increasing and decreasing nature of a given function. The problem was given in JEE Main examination held on 25th July 2021 in the morning shift. The problem is, let f of x is equal to 3 sine power 4x plus 10 sine cube x plus 6 sine square x minus 3, where x belongs to the closed and bounded interval minus pi by 6 to pi by 2. Then f is, we are given 4 options. Option 1, increasing in the open interval minus pi by 6 to 0. Option 2, decreasing in the open interval minus pi by 6 to 0. Option 3, increasing in the open interval minus pi by 6 to pi by 2. Option 4, decreasing in the open interval 0 to pi by 2. We now discuss the solution of the problem, and this is your given function, and where x belongs to the closed and bounded interval minus pi by 6 to pi by 2. Now, to talk about increasing and decreasing nature of this function, we have to first of all find out what are the critical points. To find out the critical points, we need the derivative of fx. Therefore, f prime x is equal to 12 sine cube x. The derivative of sine x with respect to x is cos x. 12 sine cube x cos x plus 30 sine square x cos x plus 12 sine x cos x, and the derivative of a constant is 0. Now this is written as 6 cos x sin x is taken out common, and we get in brackets 2 sin square x plus 5 sin x plus 2. And 2 sin x cos x, we write it as sin 2x and 3 times of sin 2x. And we factorize this, then we get 3 sin 2x into, the factors are 2 sin x plus 1 into sin x plus 2. So these are this is f prime x. And the critical points are given by f prime x is equal to 0, that is sin 2x is equal to 0, or 2 sin x plus 1 is equal to 0, in x in the closed and bounded interval minus pi by 6 to pi by 2. And we have not equated sin x plus 2 to 0. Why? Because sin x plus 2 is always greater than 0 for all x belongs to R, because sin x takes the minimum value minus 1, maximum value plus 1. Even in that case also, sin x plus 2 is greater than 0. So therefore, sin x plus 2 greater than 0 for all x belongs to R. Therefore, sin x plus 2 is equal to 0. We will not make it such a statement. So that's the one. And sin 2x is equal to 0. We have to search that x for which sin 2x is 0 in this interval. So sin 2x is equal to 0 means 2x is equal to 0 r pi, and thereby x is equal to 0 r pi by 2. And 2 sin x plus 1 is equal to 0, that is sin x is equal to minus 1 by 2. So sin 2x is equal to 0 will give you 2x is equal to 0 r pi, that is x is equal to 0 r pi by 2, and x is in minus pi by 6. We are searching the solutions x in this interval. So there are several other sin 2x is equal to 0 will give you many more values for x, but our search is in this. So we consider two intervals, minus pi by 6 to 0 open interval and 0 to pi by 2. So we have f prime x, and equated to 0, we got the critical points, and we have considered the two open intervals. And we have already noted sin x plus 2 is greater than 0 for all x belongs to R. So this part is greater than 0. Now, first case, we consider minus pi by 6 to 0 the open interval. Now minus pi by 6 less than x less than 0. In this interval, sine is an increasing function. Therefore, sine of minus pi by 6 less than sine x less than sine of 0. And this will imply sine of minus pi by 6, that is pi is 180 by 6, 30, sine 30, that is minus 1 by 2 less than sine x less than 0, and multiply throughout by 2 minus 1 less than 2 sine x less than 0. Therefore, 2 sine x plus 1 is greater than 0. So, in this interval. Now, minus pi by 6 less than x less than 0, multiply throughout by 2, will get minus pi by 3 less than 2x less than 0. In this interval, minus pi by 3 to 0, sine is positive, the sine is increasing, therefore it will be sine of minus pi by 3 less than sine 2x less than sine 0. And this will give you minus root 3 by 2 less than sine 2x less than 0, that is sine 2x is negative. So, thus f prime x is equal to this product of the three factors, wherein sine 2x is negative, 2 sine x plus 1 is positive, this is always positive, in total it is less than 0 in minus pi by 6 to 0. Therefore, f of x is decreasing in minus pi by 6 to 0. And we are applying that result. The result was, if f prime x is negative in an interval I, then fx is decreasing in that interval I. And if f prime x is greater than 0 in an interval I, then fx is increasing in that interval I. So that is the result what we are using. Let us go for the next case. We have f prime x and the critical points and the intervals, two intervals, open intervals, what we have considered. And we have already seen case 1, fx is decreasing in the open interval minus pi by 6 to 0. We have already noted sin x plus 2 greater than 0 for all x belongs to R in f prime x. And we have to decide about what is the sign for these two factors. So, now sin x is greater than 0 for all x belongs to 0 to pi by 2, right? And 2 times sin x is also greater than 0. 1 plus 2 sin x is also greater than 0 for all x belongs to 0 to pi by 2, right? 0 less than x less than pi by 2, multiply throughout by 2. 0 less than 2x less than pi. In this interval 0 to pi, sin 2x is positive. Sin 2x is positive, and for all x belongs to 0 to pi by 2. So both the factors, this is positive, and this is positive. So the product is positive. Thus, f prime x is positive in the interval 0 to pi by 2. So therefore, f of x is increasing in the open interval 0 to pi by 2. Let's look at our options. The 4 options are here, and fx is increasing in the open interval 0 to pi by 2, but it is decreasing here. But in this, our answer is this fx is decreasing in minus pi by 6 to 0, and that is appearing against the option 1, option 2. Therefore, our final answer is option 2. So that is the discussion of the solution of the problem from the differential calculus, which talks about increasing and decreasing nature of a given function in a given interval. I hope that you have understood the solution of this problem. I wish you all the best. Thank you.